Ma'am, thin layer chromatography, ma'am.
Your voice is not audible.
Ma'am,
Yeah, proceed.
ma'am, thin layer chromatography, ma'am.
Mm.
It is developed between 1900 to 2013, ma'am.
Mm.
Uh, when it is used to separate the non-volatile mixtures.
Yeah.
Uh, then types of thin layer chromatography, ma'am.
Yeah.
Thin layer chromatography for identification, preparative thin layer chromatography for isolation, high performance thin layer chromatography for quantification, ma'am.
Mm.
Thin layer chromatography for identification. Principles, ma'am.
Mm. Yeah.
Absorption chromatography, solid liquid chromatography, planar chromatography, ascending development technique, one-dimensional development technique, bicapillary reaction, open columnar chromatography, ma'am.
Okay. Okay, you
There is.
can stop. I'll ask other person. Thank you, Rubeshwaran. Very good.
Thank you, ma'am.
Mm.
Thank you.
Anybody else? Remaining chromatographic parameters of TLC. Anyone can explain what other parameters we have discussed? Make it fast. Saktivel.
Ma'am, good morning,
Yeah.
ma'am.
Good morning. Proceed.
Ma'am, stationary phase material glass slide uh,
Mm.
dimension of glass slide 2.5 to 7.5 centimeter, ma'am.
Mm.
Absorbent used is silica gel, ma'am. Stationary phase plate preparation method, pouring, dipping, spraying, and spreading method, ma'am. Absorbent used in inorganic silica gel, alumina, magnesium salicylate, calcium salicylate, ma'am. In organic cellulose,
Not salicylate, it is sulfate, calcium sulfate, magnesium sulfate. Hmm?
yes, ma'am.
Not salicylates. Hmm.
Organic in organic cellulose and acylates, ma'am. And charcoal and activated carbon, ma'am. Mobile
Okay.
phase compensation acetone and toluene
Hmm.
in ratio 2.8 volume by volume, ma'am. Mobile
Hmm.
phase maximum 10 ml, ma'am. Mobile
Hmm.
phase volume.
Yeah.
Mobile phase chamber 250 ml glass beaker with petri dish lid, ma'am.
Okay.
Mobile phase types of mobile phase, ma'am. Solvent
Hmm. According to polarity index, you have got a tabular column of solvents, right?
solvents, ma'am.
You
Yes, ma'am.
have to study and remember all the solvents with polarity index. Proceed with other parameter about sample.
Sample application 2.0 to 5 percentage weight by volume solution of uh, sulfur drugs is prescribed solvent, ma'am. Application application device capillary tube or micropipette, ma'am.
Mm.
Concentration of sport 5.0 to 15 ml
15 microliter.
microliter 15 microliter, ma'am.
Mm.
Markings it should be marked in pencil only, ma'am. And
Mm. In a TLC place, we cannot mark with pencil. So on
and
the glass, we use
marker
glass marker.
glass
Mm.
marker, ma'am.
Yeah.
And drying it should dry in air drying, ma'am.
Mm.
And calculation of RF values, ma'am.
Mm.
Ideal
Mm.
RF values 0.1 to 0.9, ma'am.
Mm. What is the nature of RF value? What purpose we are calculating RF value? What information we need from calculating RF value?
or distance from
Anybody? No, what purpose we are calculating RF value? What is the use of it? Anybody else can say? If you know, you can say others. Shaktivel, very good. You can stop now. Shaktivel,
thank
very
you, ma'am.
good. Anybody else can say about the importance of RF value calculation? What is the role of RF value in planar chromatographic techniques? Hmm? It is a qualitative parameter. Okay. By using RF value, we can identify the sample. It is a qualitative parameter. That's why you are calculating RF value for planar chromatography, either paper or TLC. Okay. So now let's proceed with the next title. That is preparative TLC. Preparative TLC techniques for isolation. It is meant for isolation. With the definition, history, all remain same for commonly for thin layer chromatography. Now let's move on with preparative TLC. What is the use of preparative TLC? It is meant for isolation. Isolate a single compound. Isolation is different. Isolation is different. Separation means you are separating mixtures into individual components where it has all the components at once. In isolation, from the separated compounds, we are isolating one compound. Okay, for that purpose, preparative TLC is used, and it is applicable for industrial scale purpose. Okay, large scale purpose, it is applied. That's why it is called as PTLC or preparative TLC. What purpose it is meant for? Isolation. Isolation is nothing but purification of a compound from a mixture of same group of compounds. Principle also similar to TLC technique, that is adsorption, solid liquid, planar chromatography, ascending, one-dimensional development, capillary action, and open columnar chromatography. About stationary phase, what material we are using? Let's move on to the preparative TLC chromatographic parameters. In that first one, stationary phase, there is a little bit difference between TLC and PTLC. Here we are using glass plates of dimension 20 into 20 centimeter. So length and width you can observe here equal distance 20 into 20 centimeters, so that only we can apply it for industrial purpose. That means for isolation purpose. Just a minute. Ma'am, சொல்லுங்க ma'am. Ma'am, class ma'am. ஆமாங்க இப்போதான் முடிச்சுட்டு வந்துட்டோம் மேம். அப்படிங்களா? இப்போ ஆன்லைன்ல கிளாஸ் போயிட்டு இருக்கு. ஓகே மேம். So what is the dimension we are using? 20 into 20 centimeter. Then only we can apply this plate for isolation. So what material it is used? Glass plate of 20 into 20 centimeter dimension. Adsorbent used is silica gel G. This is silica gel with G grade should be used for TLC also. What does G represents mean? Silica gel is what? Adsorbent. And G is a binder. Binder, what material it is it is representing the material of binder added to the silica gel. It is nothing but gypsum. Okay, GYPSUM, gypsum. It is gypsum is nothing but chemically it is calcium sulfate hemihydrate. Half water molecule with calcium sulfate is considered as binder, that is nothing but gypsum. It is added to the silica gel, that is adsorbent. Okay, so adsorbent plus binder is used as a stationary phase for thin layer chromatography. Why we need to add this binder to adsorbent means then only it binds adsorbent particles to give thin layer. You can get uniform thin layer because of it is added with a binder, so that the particles of silica gel can bind each other to form thin layer. Okay, that's why we are using silica gel with G grade of silica gel, not merely silica gel. It is added with binder, that is called gypsum. It is mentioned with G. Okay, gypsum is a binder. Gypsum chemically is composed of calcium sulfate hemihydrate. Calcium sulfate with half water molecule it has. Then method of preparation of plate is pouring method. Common method is pouring method. Among dipping, spraying and spreading method, pouring method we are using. As we have discussed in the last class itself about methods of preparation of TLC plates, here just I have mentioned what method it is, pouring method. Then what plate activation time and temperature? It varies from TLC. Since we are using highly thickness plate for isolation purpose, we need to activate the plate for 1.5 hours. Okay, 1 hour 30 minutes to 2 hours you can have to heat according to the thickness at 110 degrees Celsius in hot air oven. Okay, for TLC plates only 30 minutes heating is sufficient for activation. What purpose we are activating the plate? To retain the functional group present in the adsorbent, so it will get ready for adsorption. It will be free from other interfering materials including solvent, so that only it is heated at 110 degrees Celsius with the prescribed time. Time will be according to the thickness of plate. Time is decided. For preparative TLC, it is 1 hour 30 minutes. Okay, at 110 degrees Celsius in hot air oven, it is activated. Okay, activation time is 1.5 hours. Temperature is 110 degrees Celsius. Okay, then what thickness of PTLC will get after pouring? Means slurry over the plate will get 2 millimeter thickness, where in TLC it is of 0.2 millimeter. Here it is 2 millimeter. What is the particle size of adsorbent? Why we need to discuss particle size? If we use the same particle size, uniform particle size only, we'll be getting uniform thin layer. Okay, that's why particle size is important and it plays major role in separation of molecules. Okay, so what is the particle size range? 5 to 25 micrometer is preferred. 5 to 25 micrometer particle size is preferred. Then particle shape is spherical shape. Spherical is circular shaped particles, round shaped, spherical shaped particles with the size between 5 and 25 micrometer can be preferred to give a uniform thin layer. If you are using 25 micrometer, then it should be, all the particles should be of 25 micrometer, so that only we will be getting uniform layer. When you reduce particle size of the particles, spherical particles, surface area will be increased so that more number of samples can be separated. Okay, so that is the concept we need to discuss particle size. When particle size is increased, we can sample separation will be reduced. When particle size is decreased, sample separation will be increased. Number of sample separation will be increased from the mixture. Okay, then what is plate height? If you use spherical particles, you think that the layer is formed with uniform spherical particles. When uniform spherical particles are arranged, you will see the colored spot. It is the sample spot, but imagine this is your plate. Your adsorbent particles are spherical. If you arrange all the or if the thin layer is formed with uniform sized spherical particles, it may be arranged as a plates, layers. Okay, layers, so that the whole plate will be having many layers. Okay, so that layers are called as plates. Plates inside the TLC plate. Okay, that layer is formed with adsorbent material is called as plates. That plate height should be 30 micrometer for PTLC. For TLC also it is of 30 micrometer. If you use same particle size adsorbent, then it will create layers like plates in the thin layer. So each layer is formed with a uniform particles. I mean same sized particles of adsorbent. So that creates layers, and each layer is said as a plate, and the height of each plate will be 30 micrometer for preparative TLC. It is important. Okay, if plate height is increased, particle size also will be increased. If plate height is reduced, particle size will be reduced. If you can imagine like it is a hypothetical plate. Okay, so in each plate one sample can be separated. So one sample plate I'm representing here layers of adsorbent materials. Okay, so in each plate one sample can be separated. So when you increase number of plates in the plate TLC plate, you can separate that many number of samples. Okay, so each plate height is what, 30 micrometer. Each plate height, each layer, hypothetical plate in the TLC means layer is called as what plate, that is the hypothetical plate, and the height should be 30 micrometer. When it is increased, number of samples also can be number of sample separation also will be increased. Plate number of plates, if it is increased, then number of samples can be more number of samples can be separated. If plate height is or plate numbers is reduced, it is vice versa. Okay, it is defined with particle size only. When particle size is reduced, plate height also will be reduced, so number of samples can be separated. When particle size is reduced, surface area will be increased, so more number of samples can be separated. That is the concept we are discussing. This three parameters: particle size, particle shape, and plate height. This is most important in separation, either in column chromatography or in TLC when we use adsorbents. Okay, so what are the points under stationary phase we have discussed? Material, that is glass plate we have used. Then dimension of the glass plate is 20 into 20 centimeter. Then adsorbent used is silica gel G. Then method of preparation is pouring method. Plate activation time and temperature is 30 minutes. Activation time, temperature 110 degrees Celsius in hot air oven. Then thickness of PTLC plate is 2 millimeter thickness. Particle size should be 5 and 25 micrometer, between this range. And then particle shape is spherical shape. Then plate height should be 30 micrometer. This plate height is not representing the length of the plate, dimension of the plate. It is not mentioning this. Okay, it is in centimeter. Micrometer plates are representing layers formed with a uniform sized adsorbent. Okay, and this plate height decides number of samples to be separated in the plate. Okay, and it is increased by reducing the particle size of adsorbent. Clear? Then let's move on to the mobile phase, the second parameter. Type of mobile phase used is either polar and what?
Excuse me, ma'am. Ma'am,
Yeah.
in stationary phase, I have one doubt, ma'am.
Yeah. Ask.
Ma'am, if plate height increases, particle size increases, then
Particle
how
size increases. When plate height
sample
increases,
separation?
sample number of sample separation will be decreased. When number of plates are increasing, okay, particle size, when it will be increasing with the prescribed what plate height is the plate length 20 centimeter, right? In 20 centimeter, if only 10 plates are there, then 10 plates I'm representing 10 layers of your adsorbent material. If 10 plates only are there, only 10 samples could be separated. If you reduce particle size, then it will be increased with number of plates, right? So that many, it may be increased to 20 numbers. So if from 10 to 20 plates, if you are increasing, then 20 number of samples can be separated. Previously, when particle size was increased, plate height also was increased, so that number of sample separation was decreased. When it was 10, only 10 samples can be separated. If you are decreasing particle size, then layer formation also will be increased. So plates, number of plates also will be increased. So that many number of samples can be separated. So it will be increased. Got it?
Okay, ma'am.
Plate height and particle size is inversely proportional to the number of sample separation.
Okay, ma'am.
Got it? Plate
Yes,
height
ma'am.
is different, number of plates are different. Number of plates, when it is increased, number of sample also will be increased. Separation. When plate height is decreased, then only number of sample will be increased for separation. It is inversely proportional. Particle size and plate height are directly proportional, and where particle size and plate height is inversely proportional for the number of samples separation.
Okay, ma'am.
Okay. About
Okay.
plate height and other these parameters we'll be discussing under column chromatography briefly. That time you will understand what is actually the plate height is. Okay. It is
Okay,
a
ma'am.
plate. We are assuming that uniform sized particles are forming thin layer of thin layer to give a TLC plate for separation. And each layer, formation of each layer is considered as each plate. The height of plate is here 30. It is optimum height for PTLC, that is 30 micrometer. If it is reduced to 10 micrometer, then 10 micrometer plates will be more. So when we will get a reduced height, when we decrease the particle size, we will be getting decreased plate height. So number of plates within the prescribed length of plate will be increased, so that number of samples also will be separated. More number of samples can be separated.
Okay, ma'am. Thank you, ma'am.
Got it or not?
Yes, ma'am. Got cleared, ma'am.
Okay. You should have confused with plate height and number of plates, I think so. Number of plates will be increased. That is inversely proportional again. Plate height and number of plates are inversely proportional with the given length of your plate. That is glass plate. Okay. In 20 centimeter, if you are using 10 micrometer plates, like unlike 30 micrometer, then number of plates will be increased. So number of samples can be separated. If you use with a 20 centimeter glass plate length, if you use 30 micrometer, then only 30 micrometer plates will be there. So that many number of samples only can be separated. That is the hypothetical or imagined plates with imaginary separation. Next, we'll move on to the mobile phase. So type of mobile phase can be preferred as it will be composed of mobile phase will be composed of either polar and non-polar solvents. And the list of polar and non-polar solvents also we have discussed in the last class. You go through that table of solvents with polarity index. Okay. Then mobile phase chamber for preparative TLC is glass tank with stainless steel lid is preferred. Glass tank, you can observe with the stainless steel lid can be preferred as mobile phase chamber. Then maximum volume here is 100 ml. Where in TLC it is 10 ml, here it is 100 ml. So it consumes more mobile phase volume here. More mobile phase solvent is used for preparative TLC, since it is applicable for isolation and more thick plate or plate we are preferring for isolation. We need to use more amount of mobile phase solvent. So it is of maximum 100 ml is preferred. And chamber saturation time and chamber saturation process also similar to other techniques. 20 minutes is ideal chamber saturation time. Even the height is 20 into 20 centimeter. We can use the ideal time as 20 minutes. Or we can done this chamber saturation by lining a piece of normal filter paper along the sides of the mobile phase chamber, and we can observe how long it takes for saturation also. So under mobile phase, type of mobile phases, it will be composed of polar and non-polar solvents. Then mobile phase chamber will be glass tank with stainless steel lid. Then mobile phase volume of maximum 100 ml is preferred. Then chamber saturation and ideal chamber saturation time is 20 minutes. This is about mobile phase. Then remaining points we'll discuss in the next class. Okay, about preparative TLC. Already 10:30. And I have got a call from principal sir. I have to move. Okay. So we'll discuss remaining points in the next class. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Is there any doubt? We'll discuss in the next class. Okay.
Okay.
Okay, ma'am.
Okay, ma'am. Okay, ma'am. Thank you all.